Example 1. Derivative of a function given by a graph. The graph of a function f is given in figure 1. We want to use it to sketch the graph of the derivative f prime of x. So let's go ahead and first take a look at this graph right now. Okay, so we want to first find out where do we see horizontal slopes. So here we can see there is a horizontal line. We can call that point A, and that is where the slope is 0. And then here we also have another point called B. We can see that that slope is 0. And then we have another point here where our slope is 0, and we'll call that C. So let's take a look at the axis here. So we can say that this is 0.5. We can say that this is approximately at 1.5. This is 2. This is 3, 4, and then 5. So now at point A, we can say that f prime of the x value, where it's 0.5, is going to equal 0. So that's going to give us the order pair on the derivative 0.50. And then point B, we have f prime where the input is 1.5, and then we have a slope of 0. So that gives us an ordered pair of 1.5, 0. And then at point C, we have f prime where the input is 3, and that's equal to 0. So therefore we have 3, 0. So let's go ahead and plot these points on our derivative function here. So we know that we have 0.50. And then we know that we have 1.50. And then we have 3, 0. Again, this is 0.5, 1.5, 2, 3, and then 4. Okay, now the next thing we want to do is we want to start looking at the slopes of our curves. Now, before we do that, let's determine what's happening in our intervals. So if we take a look to the left of the graph, so as x is less than 0.5, so we can interpret that over here. We can say that when x is less than 0.5, then the derivative or the slopes is decreasing, so we know that our slopes are going to be negative or less than 0. Okay, and then in between, so again, that's going from x is less than 0.5. Now, in between 0.5 and 1.5, so in the interval from we have 0.5 and 1.5, we see that the slopes are increasing. And then between 1.5 and then 3, we can see that the slope is decreasing. So when x is in between 1.5 and 3, we can see that f prime, or the slopes, is going to be negative. And then from 3 and on, we can see that it's increasing. So therefore, when x is greater than 3, we can see that our derivative is going to be greater than 0. So now let's take a look at what the slope would be when x is 0 on the function. So let's go ahead and do that here. Okay, so what we want to do is we want to find the line that's tangent at that point. Okay, so what do we know here? Well, we know that if we wanted to find the tangent, so this line is tangent at 0. So we can say that this point here has a rise of -1 approximately and a run of +1. So that means the slope here is approximately -1/1, which is -1. So we have another point at 0 that we can call D, where we have f prime of 0 is going to have an approximate slope of -1. So now in the second interval, where x is in between 0.5 and 1.5, we can look at 1 at point 1 and find the tangent or the estimated slope there. So let's go ahead and do that. So we want to find the slope there. Okay, so here, let's go ahead and make that triangle a little better there. We can see that we have something tangent at 1. Now, as we see here, if we expand that triangle, and so again, we're just estimating here. So what is that slope at 1? Well, we can see that the rise is +1 of that slope, and the run is also +1 because it is increasing. So it's an increasing slope. So that means that the slope is approximately 1. So that means at point E, we have f prime of 1 is approximately 1. So it has a slope of 1. So now let's take a look at the interval between 1.5 and 3. And let's take a look at 2. So if we wanted to look at a line at 2, that is tangent to this curve at the value of 2. Okay, so what we're going to get is we have a very steep curve. Okay, so what is the estimated slope at that particular curve? So we can estimate that to be about, that's about -1.5, and this is 1. So we can say that the approximate slope here is -1.5. So at point F, f prime of 2 has a slope of -1.5. Okay, and then likewise, if we look at the interval between 3 and 5, and let's take a look at this tangent here. So there's a tangent line, and we want to look at this rise and run of that line. So again, it's an increasing curve, so it's positive 1.5. We can say that's 1. So we can say that at f prime of 5, so at the point 5, we can say that the estimated slope is 1.5. So now let's take a look at these points. So we know that we have A, B, and C. So here we have A, we have B, and then we have C. Now let's go ahead and plot f prime of 0, which is equal to negative 1. So at 0, we can say that here is our point. So this is point D. Okay, and then f prime of 1 is approximately 1. So that means over here, this represents approximately point E. Okay, and then f prime of 2, where we have 2, the output is negative 1.5, so it's about somewhere around down here. So therefore, there is our point F. And then f prime of 5 has an approximate slope of 1.5, so it's approximately up here, which is G. Okay, now let's go ahead and graph this function. Okay, so we know that from point D to A, we know that it's going to have to increase. So we know that the derivative, okay, when x is less than 0.5 is less than 0. So that means that it's negative. So the values of the y's are negative, but it's going to be increasing towards A, point A. Because we know that at A, we know that it's 0.50. So let's go ahead and graph that. So we know that from point D to A, we have an increasing function. Now, in between 0.5 and 1.5, we know that we have a 0 here and then a 0 here as well at 1.5. But what we do know is that the function, okay, in between 0.5 and 1.5, we know that the derivative is greater than 0. So that means it's going to increase to the point of E and then start to decrease to point B. So therefore, we're going to increase to point E and then decrease back to point B. So now in the interval between 1.5 and 3, okay, we know that the derivative is going to be less than 0, so it's going to continue to decrease, in this case to point F, and therefore it's going to have to start increasing again to point C because it's going to have to come back to that 0. So therefore, here we're going to have this function that starts to come here and then go through point C. And then here, from when x is greater than 3, we know that the derivative is going to be greater than 0. And so we know that at f prime of 5, it's approximately 1.5. So we can see that it starts to increase towards the point of 1.5, 1.5. So let's go ahead and label those points here. So we know that this point represents 5, 1.5. And again, that's the derivative. Okay, we also know that the point at C is 3, 0. And again, that represents the derivative. And then for the F point, we know that that order pair was 2 and approximately negative 1.5. And then for B, we know that we had 1.50. And then for E, we know that that was approximately 0.11. For A, again, I'm putting the prime there because those are our derivative points. We know that A had a point at 0.5 and then 0. And then for D prime, for the left of that, we know that that ordered pair was 0, negative 1. And therefore, this is the sketch of the derivative function.